Hey, how we doing today? Switch to the main cam here. Alrighty. Got work to do. There we go. Hey, hello. How's everybody doing today? Khadija, hello. Hope you're doing well today. How we doing this fine morning slash afternoon? You doing alright? Hopefully we're doing pretty good. At least I hope so. Just got done with an episode of Naruto Shippuden. I'm so sorry. I'm terribly sorry. I'm so sorry. Limit, hello. How you doing this? How you doing this morning slash afternoon? If you're watching Naruto Shippuden, 90% chance that it's probably a filler episode. You might as well just skip like half of that. Good. Excellent. I'm glad you're back. Glad you decided to make a. What do you mean you're sorry? Hey, the filler episodes really killed it. Really killed it. I ain't gonna lie. The filler episodes are just awful. Mr. McKeeg, hello. How we doing today? Thank you very much. Thank you very much for coming on and back. Good to see you once again after a little less than 24 hours. Welcome back. I hope you're doing well this morning. Slash afternoon. I gotta remember it's still slash afternoon. That was the only problem with Naruto. Naruto is a great series, right? I'm so sorry. You're gonna have to learn one thing. You're gonna have to learn one thing, Khadija, and that is, oh boy, Naruto Shippuden is full of filler. I'm not gonna spoil anything, but you have to understand you have to like skip a lot of episodes so it lines up with the manga. Okay, because a lot of the episodes were filler, just filler. Oh, that's rough. That's the problem. A lot of that stuff is not even canon, not even considered canon. That's the problem. So if I told you like, oh yeah, well that stuff is part of the lore, like no, that stuff's not even considered canon at this point. That's why you like read the manga and then compare to see where you should be at. It's a good arc actually. Have I watched Hunter x Hunter? I have watched Hunter x Hunter before, yeah. It's been a while though. It's been a very long while since I watched Hunter x Hunter. Kabuto freaking sucks. Kabuto is his own man. He does what he wants. Hello, Nicholas. Hello, Nicholas. I hope you're doing well. Yo, boy's gonna be one of those. Athena knows. How you doing this morning? Nicholas? I hope you're doing well this morning slash afternoon. Hope you're doing absolutely wonderful. Hopefully everybody's doing absolutely wonderful here today. It's on my list, but Naruto consumed a good 4 months of my life. Well, at least Naruto isn't Bleach, so I suppose there's that. I have a question about my math lab. I went to purchase the code, and there was two options. One for the $100 one for the $69 one. Do you know which one I should buy? I believe Now, if I recall, the $100 one was for like a full year access, and 69 was for like an 18-week access. You're just better off getting the 18-week access for 69 bucks if that's what it says, Nicholas. So you could just go with the $69 one. Yeah, so the $69 one is going to be the one in your best interest. Wait, what song is this? This is let me check. I this um which one is Oh yeah, this is More Than a Night. Yes. From the Toho Eurobeat Volume 16. Okay, with T Stebbins, that is what this is. Yeah, so save yourself a little bit of cash there, Nicholas, my man. Alright. Alright, so hydrate today I have some peach mango body armor light thing drink thing. Yeah, here we go. Yes. Fortunately, it was 2 for $5. All right. Let's say I ain't gonna complain. Give me 2 for $5. I agree, Athena. Mango's always good. 100%. Give me some mango lassi. That's what I'm talking about. Eat some. Give me some spicy chicken and some mango lassi. There you go. That's what I'm talking about. Yay, yay! Peach mango drink bodybuilding beverage. Yes, Steven! How we doing? Hello, hello, hello. Good morning slash afternoon. Hopefully we're doing absolutely fantastic today. Anyone here watch basketball? I mean, I saw the result of yesterday's basketball. I mean, what was it? Who came back yesterday? It was 76ers lost, didn't they? 76ers lose. I haven't been keeping up with the playoffs that well, as you can clearly tell. But I think it was the Nets, right? Because oh no, it wasn't the Nets. It was where was CP3's on? No. Oh man, why am I blanking out now? I'm totally blanking out. Ugh, this is gonna kill me. I just read about it like yesterday too. It's gonna kill me. Ugh. I was Atlanta. That's right. Yeah, I think you could I think with the Lakers now gone, you got I really it's anybody's kind of guess here. I mean, Dallas is gone too, but that was a pretty hard fought series. I think Doncic is a superstar anyway. And the Nets are so stacked, it's gonna be pretty hard for Giannis to actually actually take that series. It's very very hard. The Suns are a revolution this year. I think the Suns can go really far. If it was like the Nets versus Suns in the NBA Finals, I would take that. I would take that 100%. You know, talents like Devin Booker, on the Suns, I mean, they deserve a good shot. I ain't gonna lie. Basketball is something that needs a good overhaul as a sport right now, much like baseball. Yeah, I would watch those finals. Nets versus Suns with that amount of talent on both teams, absolutely fantastic. Suns have great depth, while the Nets have a big three, and you're hoping that Harden's gonna be healthy by the time it comes around. Clippers versus Nets would be great. I just like a more of a feel good story about Phoenix, especially coming out of the West. The Western Conference is so stacked that it's disgusting. So, all right. Yeah, a lot of you good young players right now. It's that the problem is that the conferences aren't equal. That's the problem. Steven, CP3. Yeah, CP3 does deserve it 100%. Mr. Mangoni, hello! How we doing today? Hello, E-Man. Hello, hello, hello. Good morning to both. Good morning slash afternoon to both of you. Hopefully you're doing absolutely fantastic here today. Um, hopefully we're doing really, really well. Link, hello. How we doing? Yo. I mean, you said yup first, and then I'm like, yo. Gonna roll with that. You went straight to sleep after the class? I'm sorry, I was so boring for 2 hours. It's kind of my job. I apologize, Khadija. I really apologize. That is completely my fault. Okay. I mean, look, hey, I totally understand I was so boring. You're like, man, just listen to that monotony. Okay, sir. Okay. I'm sorry, I just have different interpretations based on what you guys tell me. I'm just saying. Let me go with this. Go. All right. Alrighty. Ooh, we are here at noontime. Sounds like DBZ music? Well, I promise you it won't take 20 episodes to actually play out, alright? That I do promise. I can promise you that. Alright. Let's go ahead and get started here. Let's do some intros. And let's do the introduction and then we'll get started with some new material. Yes. Charge it up for half the season to have a 10-minute fight? Yes. I agree with this. Hey, Jess! How we doing, Jess? You got everything squared away? I hope you did. I hope you got things squared away, Jess. Hopefully that the Wi-Fi is going to be working and whatnot. It's good to see you this morning slash afternoon. All right, let's do this, ladies and gentlemen. Let's do this. Okay, let's get started today. Welcome back. Welcome back to Tuesday. I'm glad everybody is back here once again for another rip-roaring session of Math 112, another Math 112 college algebra session here today. Ladies and gentlemen, today we are going to be talking about quadratic equations and then hopefully moving on to here to chapter 2. All right? That is what we're going to be doing here today. All right. Go ahead and pause that up. Okay, so that is what's on the agenda here for today. We're going to get started with section 1.5, which is the last section here of chapter 1, and we're going to move into chapter 2 here once we get that up and squared away. There's kind of a lot of concepts here moving forward, so a lot of different methods we're going to be talking about here today. So let's go ahead and see what the story is, because, well, honestly, I don't even. Oh. There we go. Okay. Go to the big board. Oh. Alrighty, let's take a good look here we're going to start off at question 5. We did the first 4 questions last time, how we plotted points. We took a look at x and y intercepts, and those are all well and good. Great, great, great stuff. Okay, now to hopefully refresh your memory, a lot of the things that we do in class revolve around quadratic types of equations. The first type of equation that we're going to be dealing with is a quadratic equation. All right, so that's what number 5 talks about here. It says, what is a quadratic equation? The quadratic equation is of the form here, y is equal to ax squared plus bx plus c, where a, b, and c are any numbers. So I have some examples here. So for example here, I could have 3x squared plus 2x plus 1, for example, or y is equal to x squared minus 7x minus 4, or y is equal to minus 2x squared plus 5x plus 11, and they could be any numbers you want them to be, fractions, decimals, whatever you want. It doesn't matter. But these are just 3 random examples of quadratic equations of some variety. Now, what we're going to do is we want to be able to solve for these quadratic equations. All right. Are f of x are sorry, Danny. Are f of x and y the same thing? Absolutely, 1000%. We're actually going to talk about functions here once we get to chapter 2, but yes, I will say that for a definite certainty. I'm glad you're thinking about that already, because that is absolutely true. That's exactly the right mindset we want to think about once we get to the functions part there, Danny. So make your life significantly easier. It really does help. All right, so let's take a look at some methods here, and let's see how we can solve some quadratic equations using some various methods. Yay! All right, number 6, how do we solve quadratic equations by factoring using the AC method? Okay. All right, so here we have several steps here. Now I'm going to move this a little bit off to the left. All right, and let's bring out the paint tool for this. An example here together. All right. All right. Hey, FaZe, how we doing, my dude? Hopefully we're doing really good. Okay, so let's go ahead and take a look at an example. We're going to go through each step here carefully, so that way we can see how we can do the AC method here in action. Because sometimes some of the steps here, I put it down, and then they may end up to be a little bit more involved than what you thought here in the first place. But hey, you know what? Seeing in a little bit more detail, that can't hurt. Okay, let's do an example here. Examples that can't hurt, part 1. All right, let's just start off with something basic, and then we'll work our way up. So, all right, okay. So let's take a look here. It says x squared is equal to 8x minus 15. All right. So I do want to point out one thing here. Before we can get to the first part here of multiplying a times c, one thing I do want to point out here, some problems may end up looking like this. So the only thing that you need to do is make one small adjustment here. That adjustment here is to make sure you move everything over to one side of the equation. So move this over to one side, move that over to that side there. That is what you want to be doing here in this instance. Okay, so I want to put a little note here in this case. All right, something that doesn't large here. So note, move everything over to one side so that it equals 0, and that the the ax squared term is positive. Okay, it's actually easier to leave it as positive rather than having a negative, because then you'll have to do a little bit more work if you have to do it that way. All right, so want to avoid as much work as possible. So let's just be as lazy as possible. Now, the way we want to approach this is we're going to go ahead and subtract 8x, and we'll add 15 here. Okay, so we're just going to move that over to the other side. All right, so the real equation we're going to be dealing with here is x squared minus 8x plus 15 is equal to 0. Okay. All right, so that's what we have here in this particular case. Okay, now it says to multiply a and c here. Let's take a look at a, b, and c. Let's identify what a, b, and c are here according to this particular problem here. Okay, so can anybody tell me here, what would A, B, and C here be in this case? So again, I haven't quite reached step 1 here. I'm just going to just identify A, B, and C here before we get started. So what would A, B, and C here be according to this problem that I have here with x squared minus 8x plus 15? What would that be here in this case? Take care, Athena. You have a good one. Um, A would be 1. Okay, good. B is minus 8. And C is 15. Okay, that's correct. Okay, very good. All right, all of you are correct. All right, excellent. So I'm glad you all saw that A was equal to 1 here, as 1 would be in front of the x squared. And again, if it helps you, go ahead and put a 1 there right in front of the x squared as that coefficient. 100%, you can go ahead and roll with that. All right, now we're ready to go ahead and go through the steps here. Let's go through each step here carefully, and we'll see exactly what we're working with. All right. So step number 1 here, multiply A times C. So that's what we're going to do first. So multiplying A times C here, what we're going to get is we're going to get 1 times 15. And so here we just get a plain 15. Okay. Remember, the reason why here we wanted to identify A, B, and C is because signs do matter. Okay. So again, we could end up with a negative value. That can easily happen. Okay. Okay, step number 2. Find two numbers that multiply to the result of step 1 and add up to b. All right. So here's where things have to be very careful. We're going to multiply two numbers that somehow multiply to 15. That's what we found here in step 1. And they have to add up those same exact two numbers. So notice, these have to be the same exact two numbers, right? Have to add up to b. Now, b here was equal to minus 8. All right, so same exact numbers. So you can't just mix and you just can't be like, well, this is 1 and 15 and this is, 3 and 5. You can't do that. It has to be the same numbers in both blanks here. So what two numbers multiply to 15, but also multiply to minus 8? What do you guys think there? All right. Very good. That is correct. Okay. So, regardless of which way you write it, no problem. Minus 3 and minus 5, or minus 5 minus 3, either way. That's perfectly fine. All right. So, minus 3 times minus 5 is positive 15. So Jess here would be 5, not positive 5, it would be negative 5, because the problem with positive 5 is positive 5 times negative 3 would be negative 15. So you want a positive 15 here, not a negative 15. So what's a good suggestion here is just making sure you write down possible combinations if you're not sure. So you can just write down possible combinations to get 15. You could say, well, 1 and 15. Well, 1 and 15 doesn't add up to 8, so that you can rule out. You can say, okay, does 3 and 5 add up to 8 of some variety? You can say, yeah, 3 and 5 add up to 8. And since you want minus 8 and positive 15, then that forces those both to be negative. So if you want a kind of a thought process about how you can go through kind of doing a little guess and checking without having to do too much guessing, at least you can go with possible combinations to get, say, the first number, and then however you can get this second number to work out, is it realistic? You can answer that yes or no. And then you can work with that and just kind of manipulate it to see how you can get those to work out. So, all right. Okay. So let's look at the next part here then. Okay, so step number 3, split up the bx term in the original equation using the two numbers found in step 2. Okay, so what exactly does that mean? So that essentially means this. All right, now we found the two numbers here of -3, -5 here in step number 2. We're going to take this OG problem we have right here. All right, and all we're going to do is split up that -8x in terms of -3 and -5. So all we want to do, going to split up that bx term here. We're going to split it up just like so. We have -3x minus 5x, and then we have the plus 15 here as a result. Okay, so this is what we got here, just like so. Okay, so that is what I've done here, is I've split up this -8x in terms of -3x and -5x. All right, so this will be important here for what we want to do next, but I'm just going to point that out right now. Okay, let me know if you guys got any questions for this, as I know I'm going through this a little bit quickly. So, but just let me know if you guys do have questions. Just stop me and just let me know. Oh, all right. All good. All good. Um, all right. So let's look at step number 4 is factor by grouping. Okay. Now, I do want to talk about this here specifically. Let's talk about what factor by grouping actually means. Factor by grouping is a technique where we take, in this case, we're going to just kind of do a few underlines here. So we're going to underline the first two terms. We'll underline the last two terms here. All right. And we're going to take each of these as an individual group and basically factor them out. So what does that mean here? Well, we take a look at x squared and -3x, and we say, okay, well, let's factor something out in common between both of those terms. And there's only one thing in common between both of those terms in this case, and that is x. Okay, so x is the only thing in common here between x squared and -3x. And then we get whatever's left over here, which is x minus 3. Okay, now, the next part here is going to be very important. All right. Now, this is extremely important because of the effect that it does have on the rest of the problem. So please be very careful here. This is the part that kind of where we talk about sign changes. This is where we have to be a little bit extra careful. So this sign here in the middle has to come down. Whether that this is minus or whether this is plus, that sign in the middle must come down. And you have to make adjustments based on that sign that is forced to come down. So I will put this as a little side note here. I think it's pretty important here. So note sign in the middle must come down. All right. All right. So what we want to look at here is we look at 5x and 15. Now, of course, there's only one thing that's in common here between 5x and 15, and that is going to be 5. However, what you've effectively done here, more importantly, is you've actually factored out not just a regular 5. Because you brought that sign down, we actually factored out -5. Okay? And that's why this is so important here. Because we factored out -5 here, okay, we're actually taking, like, say, -5x and taking away another -5. So these signs here are going to change. All right, so if we take out a -5 from -5x, we actually have just regular 1x left over, positive x. And if we factor out -5 here from positive 15, then you could say, well, 15 divided by -5, that's going to be -3. So really quick here, are there any questions about that particular part? Well, I want to be sure that that's pretty clear about how I found out we got -3 there, okay, instead of +3. So that's the most common mistake I see in these problems. All right. Even if they're easy, we don't take it for granted. So that's the one thing I want to be sure that we don't take stuff for granted. That's what we want to do. Like I said, I know some of you know this like from seeing it a long time. Maybe you've done this a ton of times, but one thing that we don't do, at least the one thing that I don't do in a math class, is you never take any problems for granted. So just try and be as consistent as possible. That's what we're after here. Okay. Now we have this whole group here, and all we're going to do now is then go ahead and we're just going to go ahead and do this one out. All right, so we're just going to see what's in common between these two terms here. And we see what's in common here is x minus 3. So we're just going to go ahead and factor that out there. So here we got our final factoring here of x minus 3. We have x minus 3 in both those terms and the x minus 5 here that's left over. And there we go. Got it. That'll be step number 4 here, done and dusted. Okay. Okay, now I did add a step 5 here. This is applicable to pretty much every single one, and you probably will have to use it for these problems anyway. So step 5 here, if necessary, just depends. In this case, it will be necessary to solve for x if in the equation if necessary using the zero product property. I should say in the equation if necessary using the zero product property. So the zero product property meaning to say if we're going to solve for x in this equation, all right, we're going to set both of these factors here equal to 0 and then solve for x. Okay, so simply put, as easy as pie, I'm just going to set x minus 3 here is equal to 0. Set x minus 5 here is also equal to 0. So here we're going to add 3 to both sides. All right, so here we get one answer here of x is equal to 3. Easy peasy. Rinse and repeat here for the other guy. All right, and so here we get something that doesn't look terrible. So x equals 5. So we get a 2 for the price of 1 here. So x is equal to 3 and x is equal to 5. Again, this is applicable because of the fact that we have something equal to 0. If you don't have this something equal to 0, then you could just leave it as x minus 3, x minus 5, and call it a day. All right, so if you don't have it equal to 0, well, don't worry about it. Okay, so no big deal. All right, any questions about that so far? All right. Oops, not mean. Okay. All right. Let's go ahead and try another example here then. Do another example. My God. All right. Another example. Yes. Yes. All right. Only reason why I do another example is just to give you another look with different numbers. So let's try this one here. Plus 9. All right. So we'll go through this a little bit faster now that, oh, that should be plus 2. All right. All right. Okay. So this one here will go a little bit faster. We're just going to hopefully uh, truck through these steps here. All right, let's do step 1 here. Step 1 here is do A times C. So A times C is 9 times 2. Again, if you want to, write A, B, and C here. A being 9, B being 9, and C being positive 2. Hello, hello, hello. All right. So here we have 9 times 2. That's going to be 18. That part's not too hard. All right, let's do step 2, though. Step 2, probably the more important of the two steps here. So we want two numbers that multiply to 18, and those same two numbers multiplying to 9, all right? All right, so what two numbers multiply to 18 and also add up to 9? Numbers that multiply to 18 but also add up to 9. All right, very good. Okay. All right, so 6 and 3, 3 and 6, either way, no problem. All right, good stuff. So the question is, what do I write for step 3 then? So I agree. 3 and 6, 6 and 3, whichever way you want to write it, perfectly valid. All right. So how am I going to write out step 3? I need to, how should I write out step 3 then? What should I have? 6 plus 3 squared? Let's go back, look at our step 3 here from before. Take a look at what we did here. Is that what I did here in this step 3 where I rewrote this equation? 9x plus 6. Like I said here, this is going to be the crux of the issue. You need to look at how I rewrote step 3 here. How do we do? 9x squared plus 6x plus 3x plus 2 is equal to 0. Okay. There we go. Now, again, that's what we're doing here for step 3. This is why I'm asking the question here. Be like, okay, I have to rewrite this middle term here. So notice everything on the outside stays the same. The x squared, like in the previous example, the x squared and the 15, they stayed the same. No problem. It was only the middle term, the bx term, that I split apart into the two numbers that I found here in step 2. So that would be correct here from Danny and Carla here. Be like, okay, well, I have 9x squared here. That's what I had to start with. But it's just the thing that changes is this 9x. It'll just be rewritten in terms of 6 and 3. So it'll be 6x and 3x. Okay. And then the plus 2 stays the same. All right. So I'm just going to point out that's what we're doing here for step number 3. All right. Just to make it as clear as possible. That's what we're doing here. All right. So just to reduce the amount of confusion, right? That's what I kind of want to say here is like, okay, how do I make sure I'm not really guessing here? Again, just try to be as consistent with the steps as much as possible. That's exactly what we're after here. All right? All right, are there any questions about that before I move forward? No? Okay. All right, good beans. Good beans. Good beans. All right. Let's do some factor by grouping. Let's do it. Yeah. All right. Back to this and back to this. All right. Okay. So let's take a look at the first group here. All right. So what is the what can we factor out of the first group? What can we do? Three x sounds like a plan, right? 100%. 100% agree, everybody. 3x is our friend. Now, if we factor out a 3x, what we have left over here is we have another 3x, and we have 3x, 6x divided by 3x is 2, so plus 2. Yeah. Winner, winner, chicken dinner. Easy peasy lemon squeezy. All right. And we're going to bring down this plus sign here. Bada bing, bada boom. Got it. Okay. What can we factor out of 3x plus 2? What can we factor out of 3x plus 2? What can we factor out of there? A 1. That is correct. Okay, good. So that's the next note I'm going to put down here really quickly, just to hopefully help everyone here. All right, so let's put another note here. Um, note here, if nothing is in common, you can always factor out a 1. Okay? So if nothing is in common, you can always factor out a 1. So it's like, okay, there's absolutely nothing in common between 3x and 2. It'd be like, absolutely, except for 1. All right? 1 pretty much divides everything. So that's the only thing that we can roll with at the end of the day. So we can factor out a 1, and that leaves us with the same thing that we started with, 3x plus 2. Okay? All right, so very nice job, you guys. Nice work. Now we just go ahead and factor out the stuff here. So we get 3x plus 2, and we get the 3x plus 1 here. And there we go. We've successfully factored here in step number 4 here. And then finally, step 5. Let's go ahead and solve for our 2x values. We're going to set does the order matter here in step 4? So if you're referring to like 3x plus 1 times 3x plus 2, the answer is no. Order doesn't even matter for how you rewrite the bx term. You could write 3x and you could write 6x and you'll end up with the same answer. So that's what's really convenient about this, is that you don't have to worry about like messing. You don't have to worry about like it being necessarily in order, or it doesn't matter. So you're going to end up at the same result either way. Now, let's talk about step 5. I'm going to talk about step 5 here really quick. Now, we can easily find the answers here, but that's not the important point I want to make regarding this last step here. I see the most common mistake people make is assuming what the answers are. So if you are assuming that the answer is positive 2/3, I'm going to assume that I'm going to be marking it wrong on your test. That's just the assumption I'm going to make right away. All right. The real answer here instead is if you should be writing out the work here. All right. Because then there will be lots of sadness. All right. So in this case here, you're going to get negative 2/3 and not positive 2/3. The most common mistake I see is usually at the end of the problem right here, is just assuming, that's the sign because I see pluses, so my answer is going to be pluses. And I'd be like, bruh, that's why we're here. Okay, so I'm like, that's what we gotta work on that. Okay, so gotta gotta make sure we work on that. A little important here. We'll subtract by 1 on both sides. Remember, get 3x is equal to -1. Then we divide by 3 here, get ourselves a winner. X is equal to -1/3. So we have our two answers here. We get -2/3 and we get -1/3. So it's not exactly as you thought. Go ahead and write out the work, and you'll be pleasantly happy. That's one thing I can tell you. Alrighty. Okay. Any questions about that? Any questions about that example? Oh, good stuff. Good stuff. Good stuff. Alrighty. Okay, so that is the answer here for number 6. All right, let's move forward here. Let's go through the other types here, and go ahead, and on these next two problems will be rather quick, a little bit quicker, since we now have a good foundational basis for what we're going to be doing here. All right, number 7. How do we solve for quadratic equations by the square root property? All right, so let's take a look at several problems here, and let's talk about how we can do the square root property. uh, Not too hard, that I promise you. All right, let's start off with something easy, and then we'll work our way up from there. Okay. All right. Section this off here. Okay, I'll go ahead and put this over on that. Okay, so the first thing we're going to do is let's go ahead and write down an example here for this one. And that one's okay. Okay, greatest. Okay, that's fine. All right. I just want to pick a problem that actually is going to make a lot of sense. Okay, so here is 3 times x minus 4 squared is equal to 15. So this is a good problem here because this will help highlight exactly some of the things that we'll be talking about in each one of these steps. So let's look at step 1. Step 1 says move everything but the squared term to one side of the equation. So as we can see here, the squared term is the x minus 4 squared. That's the x minus 4 part there. That's the squared part. So we're going to leave that part alone. However, the thing that is going to be a little bit different here in this case is we're going to take this 3 and we're going to move it to the other side. So we're going to go ahead and divide by 3 on both sides, just like so. So what we should get here is we should get x minus 4 squared is equal to 5. All right. So we have x minus 4 squared is equal to 5. Then we do step number 2 right after that, and that is to take the square root of both sides. So this part here, not too tough. Let's take the square root of both sides, just like so. Actually, let me put that on a separate line. Two things at the same time, put it as separate. All right. So we take the square root of both sides. Now, what happens to the square root in a square? The square root and the square will effectively cancel each other out. So those will cancel each other out. That'll leave you with x minus 4. However, I did put a little note in here in this instance that it says you will have both plus or minus roots on the side of the equation that was not squared before. What does that exactly does that mean? Probably saying, whoa, 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 time out. It's a little bit confusing. But we did take the square root of 5, and technically, we have the square root of 5, but that's not the only answer we get. We don't just get positive square root of 5, we also get negative square root of 5. So we actually have two answers for the price of one. We have positive square root of 5, which is a given, but we also have negative square root of 5. So you get both plus or minus square root of 5. So in fact, what we do have is we're going to have two answers here for x, because we are going to have two equations to solve for x. All right, so we have our two equations here, and that'll be step 3, essentially. So we're going to have x minus 4 is equal to square root of 5. And x minus 4 is equal to negative root 5. And we're just going to do the algebra after that, and we're going to find our two answers here. Easy peasy, lemon squeezy. Let's do this here. We'll do add 4. We'll add 4. So what are our two answers here? Our two answers here is x is equal to 4 plus square root of 5 and 4 minus square root of 5. And those are our two final answers here for this problem. Okay, so those aren't too bad. Again, a little bit getting used to sometimes, but hey, no problem. Check that. All right. Any questions about that so far? I'm gonna do another example here real quick, but no. Okay. Stuff. All right. Now this next example here can be important. So I'm just going to kind of reiterate here this next example. Nope, okay. Let's try this one here. Okay, so we get 2x squared minus 7 is equal to negative 15. All right, so what we're going to do here first, we're going to move everything over that isn't squared over to one side. So first we're going to add 7 to both sides. So here we get 2x squared is equal to negative 8. We're going to go ahead and divide by 2. So we divide by 2 here. So here we get x squared is equal to negative 4. Okay, so we'd have x squared is equal to negative 4. We're going to go ahead and take the square root of both sides. All right, so here on the left-hand side, we're definitely getting x, 100%. 100%, I totally agree getting x. All right, now, what's the square root of minus 4? What is that going to be? Anybody tell me here, what is the square root of minus 4? 2 or minus 2? 2 or minus 2 would be the square root of 4. I would say 2 or minus 2 would be the square root of 4. Can't do a negative. Can't square a negative, okay? I agree, you can't square root a negative, except in what case? What is the one case where you can square root a negative number? Ah, there we go. There we go. That's right. The imaginary I number. That is correct. Okay. So I agree with, say, oh, 2 and minus 2 would be like, yes, if it was just 4, I would agree. Now, in this case here, we are taking the square root of a negative number. So we are now including imaginary numbers. So imaginary numbers are in play here for these problems, okay? So I want to point that out here specifically because that wasn't mentioned here before, and it needs to be stated. So note here, imaginary numbers are in play. All right. So in this particular instance, what's an imaginary number? Just to kind of hopefully refresh yourselves here. So the way it works is, if you remember from maybe way back in the archives, that the square root of minus 1 is equal to this imaginary number I. Okay, that's how it works. All right. Square root of minus 1 is equal to the imaginary number I. Now, if we take a look at the square root of minus 4, the square root of minus 4 can be broken down into two parts using a property of square roots. Is that if you multiply two things together, you can multiply it into that number, i.e., you can have square root of minus 4 here, for example, can be the square root of 4 times the square root of minus 1. So now I can take away the thing that was said earlier. The square root of 4, I completely agree, is plus or minus 2, 100% absolutely true. And we also have the definition here of the square root of minus 1, which is I. So we have here is we have x is equal to specifically plus or minus 2i as our answer. Okay, so you can split apart square roots like so. And then since we have the definition here of the square root of minus 1, because technically it's true, you can't take the square root of any negative number. Can't really, unless we involve I, the complex numbers. So definitely imaginary numbers are in play, so please keep that in mind. This is not the last time we're going to see imaginary numbers, as you can tell. All right, so I want you to kind of get in the mindset here to be like, yeah, we're going to see this again. It's going to pop up here. At least let's get a good handle about, what it's talking about here in problems like these. All right? Okay. All right. Any questions about imaginary numbers or anything like that? Everybody's okay with that? Like I said, we're going to see more of this later on here. Um, right now it's just kind of like a beginning, but still. All right. Good beans. All right. Next, let's go to number 8. All right, number 8. I think I'll only do an example for that guy. Um, all right, number 8. How do we solve quadratic equations by the quadratic formula? All right. All right, so let's go over the steps here. Let's do this. Number 8. Okay. Solve for y by moving all the x's and numbers to one side of the equation. Identify a, b, and c, and then use the quadratic formula. All right, just wants me to hydrate. You got that. Danny says, so basically negative numbers, yes. So if we're taking the square root of negative numbers, we're always going to get an I as a part of that answer. So just to be clear about what I'm talking about there, Danny. If we're taking the square root of a negative number, we're going to have an I involved in the final result. No problem, man. All right. So let's take a look at an example here for number 8. And let's go ahead. Oh, no. That one's poop. All right. Okay. So let's do this one here. All right. So everything is on one side of the equation. All right. So we have x squared minus 6x minus 11. All right. Now, we have everything on one side of the equation. We're fine there. No problem. All right. What we need to do next is to identify A, B, and C here. Once we identify A, B, and C, we're going to be good to go. All right. In terms of plopping stuff down. Or ploppingtons, indeed. All right. So let's first identify A, B, and C. What is A, what is B, and what is C here according to this process? What is A, B, and C here according to this particular equation that you see? 1, -6, and -11. Okay, good. All right. I'm liking these answers. All right. Yes. Wahaha. That is correct. Okay, very good. All right. Now, for these particular type of problems, well, I'm just going to point it out here. For these particular type of problems, okay, you can try other methods before you try the quadratic formula. One of the things that I will point out regarding the quadratic formula is you should use this as a last resort. If the first few methods that you try do not work, try to use this as a last resort. So I will put this on the main notes here in this instance, and that is uh, note use as a last resort once you try other methods. So if the other methods don't work, if like the AC method doesn't work out, or you go and you can't really factor it that easy, then it's like, okay, you know what, this doesn't really factor to nice numbers, I can't really get it to work out, then we use this as the last resort in order to get our answers that we're looking for here. So, and again, the reason why I say that is because the AC method takes a little less time. It takes less time to do than doing the quadratic formula, and it's less confusing. So those people who's like, oh, I should just go to the well every single time a quadratic formula. As you can tell, that can be a little bit more daunting than really what's necessary. Um, okay, but let's plug it in here again. The quadratic formula here is x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so all we're going to do is plop in some numbers, and then we're going to see what we're going to get after we put it all together. Remember, though, anything we plug in, we're going to put parentheses around. That's going to be important here. So let's go ahead and do it. So x is equal to -b, so -6, plus or minus the square root 6 quantity squared. B squared minus 4 times A times C. Okay, all that over 2 times A. All right, there we go. All right, so now we have that in there, no problem. Okay, so here we have negative 6. That's going to be positive 6. All right, so again, that's why we put it in parentheses. Note those sign changes. All right, let's take a look what's underneath the square root because that's going to be the toughest part, of course, usually is. All right, so here we have negative 6 quantity squared. That's positive 36. And we have negative 4 times 1, negative 4 times negative 11. That'll be plus 44. All right. And that'll all be divided by 2. So just to clean this up here a little bit, we have 6 plus or minus the square root of 80 divided by 2. Okay. So that's what we have here so far. Okay. Now, we'll need to go ahead and clean this up a little bit further. So again, we have the square root of 80. So with the square root of 80, again, if you want to kind of figure this out here, this will be kind of an aside thing. The square root of 80, it's over here, little space. Again, the square root of 80 here is essentially going to be the square root of 16 times the square root of 5. And we have the square root of 16 here, which is going to be 4 times the square root of 5. Now, I know that says 8.9, but I'm not going to be using decimals here. All right, so we're not going to be using decimals. We're going to be using the exact form here. Again, that's what's going to be also expected here when you put that into my math lab. All right, so albeit decimals are great, what we want is the actual exact value here. And to get the exact value here, we need to simplify it down. Okay, so I'm just going to point that out here. That's the kind of the expectation here for these problems. That'll be also the expectation for the homework. All right, so again, like I said, it's super easy to put it into the calculator, 100% true, but that's fine. Okay, so yeah, I can certainly do that. All right, so to kind of clarify here, I need to find two numbers that multiply to 80 that I can take the square root of. So 16 times 5 is equal to 80. So just maybe I'll show it this way. So again, you can split up 80 as to 16 times 5. This is perfectly fine. The reason why I specifically chose, how do I know it's root 16 and 5 to get root 80? Then that's a property of square roots. So a property of square roots is this. The property of square roots is you have the let's say you have the square root of a times b. You can split those up into two separate square roots. This is entirely plausible underneath square root properties. All right. So this is the property that we're going to use and exploit. So that way we're able to basically separate it out and then take the square root of, say, one particular number. So that's what I decided to do. I said, okay, you know what? 80 is 16 times 5. Now I specifically chose 16 and 5 here because I can take the square root of 16. That actually has a tangible root of 4, right? That's the root 16. That's why it's 16 times 5. And then I can just use that property that you see down here, and that's where I get the square root of 16 times the square root of 5, just like so, and where I get 4 square root of 5. I can't do much with square root of 5 because it doesn't translate to anything, but the square root of 16 certainly is 4 here in this case. Now, let me take it a step further. Let's say, for example here, you're not sure how I got 16. Let's make sure, let's say, you know what? 16 and 5 weren't the two numbers that came into your mind right away. I said, that's fine. Let's try and make it as easy as possible. Let's break it down, and it may take you an extra step, but that's perfectly fine. You're like, you know what is an easy number for me to take the square root of? 4. 4 is an easy number to take the square root of. I'd be like, yeah, I'm not going to disagree with that. I'd be like, all right, the square root of 80 is the square root of, is 4 times 20. I'd be like, yeah, that makes sense. I'd like that be the square root of 4 times the square root of 20. Be like, yeah, all right, that makes sense. 100%. They'd be like, okay, well, the square root of 4 is 2. Be like, all right, simple enough. 100%, 100% true. I said, can we break down 20 any further? Be like, yeah, I can break down. I can break that down. I said, sure. Break that down further. Be like, all right, okay. Well, 20 can be broken down to 5 and 4, right? Okay, so let's do that. So we still have the 2 out here. Okay, so we still have the 2 out here. Let me expand this out. So we still have the 2 out here. No problem. And I'm like, all right. Well, that's going to be the square root of 4 times 5, right? So I'm going to have here, let me write it down here. 2 times the square root of 4 times the square root of 5. I'll be like, all right, fair enough. Now we already know the square root of 4 is 2, so we have 2 times 2 times the square root of 5. Now this is a long way to get here, but you know what? Some people it works out that way. I have no problem doing it this way. And so we still get the same answer here of 4 times the square root of 5. So is 16 the highest number you can square root when simplify? So is 16 the highest number you can square root when simplified by 80? Yes. Yes, it is. So you're just trying to find the number that'll divide 80 that you can take the square root of. 16 is the biggest number. That's right. But again, you can do it the second way. You could say, you know what? I like doing it with smaller numbers. I said, fine. Absolutely, you could do it with smaller numbers and you'll arrive at the same result. It's going to take you a little longer to get there, but it's not wrong. All right? It's not wrong by the slightest. You say, you know what? I'm used to 4, I'm used to 9, I'm used to 6. I'm used to those. Like, okay, take it in smaller chunks. You're more than welcome to do so. Okay. So again, 1's a little bit more direct because we use 16 right away. But hey, you know what? There's no wrong way to arrive at the same result if you're just arriving at the same result. So, like, it's the same result. So, yeah. It's the same answer. What's wrong? Nothing. Okay. Sheesh. Yeah, no problem. All right. So you're trying to find the biggest factors of the original root number. I try and find the factors of the original root number that I can take the square root of. So I'll be a little bit more precise. Again, you want to find the largest numbers that divide out that number, that original root number that you can take the square root of and get a nice answer out of. That's what we're after there, Fritz. And it may not be nice numbers, by the way. By the way, it may not be the nicest number. That's you just kind of are guessing and checking as you go down the line. So, you can look up your numbers of squares. That's perfectly fine. You say, okay, does 64 divide it then? There you go. All right, just says, so do we then plug this answer into the equation? So what we effectively have done is we haven't really we're not effectively plug it into the equation. We're just effectively simplifying the equation here. So to kind of answer your question here, this is where we're at. We're right here. So this was all kind of side scratch work here. We're right here at this point. We have 6 plus or minus the square root of 80 over 2. So by simplifying this down, we have 6 plus or minus 4 square root of 5 divided by 2. Okay? That's correct. That's correct. Yes. Yes. Yes, Ms. McKee, that is correct. 100%. Yeah. Now, I am going to take this one step further, so I know you're going to hate me for this. All right, but it is important because you do have to simplify as much as possible in order to put down these final answers down. So one of the things is we want to simplify this answer here. Now you're saying, well, wait a second here. Hold up. Now, I could say divide by 2, okay? Now, that part is true, but I will mention this, okay? And this is kind of one of those little sneaky things that can happen in some of these problems. Okay? Is that yes, we can divide both of them by 2, but one of the things I always recommend in these type of problems, to be more specific, is to split it up into 2 separate fractions. So that's kind of the trick I want to talk about here in this case. So the key here at the end is to split it up into 2 separate uh, fractions, and then simplify. Because in some cases, as you'll see in these problems, sometimes the first one simplifies, but the second one doesn't. So what do I mean by splitting it up into 2 separate fractions here? What exactly am I referring to here? Let me go ahead and show you here. What I'm referring to is this, and that is so we have 6 plus or minus 4 root 5 over 2. Instead, what we're going to have here when we split that up is we're just going in reverse. Like, hey, we have a common denominator of 2, so we're just going to do 6 over 2 plus or minus 4 square root of 5 over 2. And then we go ahead and simplify based on what we see here. So 6 over 2 would be 3. Then you have plus or minus 4 divided by 2 is 2. So this becomes 1, this is 2. So then we get 2 square root of 5. Now, it's not always, by the way, not every problem is going to have nice answers that look like this. Imagine if this was 3 square root of 5 over 2. Well, then we'll just have to leave it like that. Okay, so that's how we can split it up into 2 separate fractions and then simplify. So I just wanted to point out here, this is going to be our final answer. We have 3 plus 2 square root of 5, 3 minus 2 square root of 5, and that's going to be our final answer for this problem. Any questions about that? Okay. Yeah, so I just wanted to be a little bit more clear about that last part there. Because again, unlike my math lab and for the homework, that they're going to expect for you to kind of do that little last bit there. So, want to be sure that I remove the confusion. Yeah, I can see why this is last resort. Yeah, exactly. That's the issues. Like sometimes you learn in high school, you're like high school, or you learn it earlier. It's like, well, or learn it a while ago, and you're like, oh man, I could just use this right away. I'd be like, sure you can. Go ahead. Have fun. Hmm. Yeah, exactly. You're like, let me tell you how it really is. There's a reason why it's there. It is consistent, but it's a pain in the butt. 100% it's a pain in the butt. All right. So that is the quadratic formula there. Okay. Let's move on to the next question here. Probably the last question here for this section. There's a lot of things to cover. Relationships really clears the cobwebs. It's true. You gotta clear the cobwebs. I've been there, man. It's you don't do a subject for a while. It really is like it really is a pain to kind of get that stuff back without doing a little bit of review. Or heck, let's be honest here. Once you're done with the class, I know what happens. Okay, I know what happens. You're done with the class. Let's say you're done with finals and stuff like that, and you take 2 steps out of your classroom, and you take your right hand or your left hand, whichever one's your dominant hand, right? And you take it next to your temple here, and you just go flush, and you're like, all that stuff all out of the way. You flush it directly out of your brain. You're like, let me look at the next TikTok video. That's what we're gonna be doing. No. I know how it is. I know how it is. We've all been there. We've all been there before. It's serious. We've all been there. All right. Next part here. Take a look at the next part. Figure this out. Draw this junk out. Oh. Take that hand. All right. Hey, trust me, I did the same thing. I ain't gonna lie. There's some subjects that I do. Some subjects like I wish I did. I wanted to forget as soon as I walked away. I don't want to remember that. I don't want to remember that. Those things that scarred me for life. All right, so let's look at number 9. Number 9 says, "How do we solve quadratic equations by completing the square?" Sal Bender, thank you for the posture check. Appreciate that. Um, how do we solve quadratic equations by completing the square? Um, okay, so completing the square is the last thing that we're going to talk about here in this section. Now, completing the square is something we're going to be seeing late in the semester as well. So this is not going to be the last time we're going to see completing the square. We're going to be seeing this, I believe, in the next chapter, and we'll also see this a little bit later in the semester as well. So we're going to be coming back to this process here a few more times, maybe a couple more times. All right. In any case, let's take a look at an example. We're going to go through the steps here, and we'll see exactly what we're working with. All right. Let's do this example here. Okay. uh, okay. So this is what we have here. We have x squared plus 6x minus 5 is equal to 0. Okay. Our goal is, of course, once again, solving for x, no problem. Now, it looks like we could go ahead and do the AC method, but I can tell you right now, if you try the AC method, it's really, really close, but you're actually not going to find two numbers that multiply to minus 5 and add up to 6. All right, so unfortunately, that just doesn't happen in this particular problem. You can try, but it won't work out that way. Um, now, again, you could do the quadratic formula. That's perfectly fine. You could also do here completing the square, which is the other method here. Now, completing the square here, what we're going to do here is let's do the first step here. Move all the x terms to one side of the equation and the numbers on the other side. So essentially, what they would like us to do here for the first step is essentially take this minus 5, and we're going to just move it to the other side of the equation. We'll keep all the x's on one side, move the numbers here to the other side. So we're left with x squared plus 6x is equal to 5. Okay, so this is what we have first and foremost. Okay, step 2 is to take b, divide it by 2, and square it. Take b, divide it by 2, and square it. So we're going to take this b term here, this b, it's like in the quadratic equation, you know, ax squared plus bx plus c. Take that b, which is 6, we're going to divide it by 2, and we're going to square it. So 6 divided by 2 here is 3. So 3 squared here is going to be 9. Okay, so here we get 3, and then 3 squared, we get 9 there. There we go. That is step number 2. Okay. All right, let's look at step 3 here. Step 3 here is to take the result of step 2 and add it to both sides. So this is the most important part here as part of this process, is that we need to remember in algebra, one of the things we always say in algebra is the word balance. This is definitely where the word balance is definitely going to come into mind. Again, we are playing a zero sum game at the end of the day. So if I have 9 here, I'm not only going to add 9 to one side, I'm going to add 9 to both sides of the equation. Okay, if I'm going to play a zero sum game here. So I have x squared plus 6x, definitely true. All right, but we're going to add 9 here. All right. And then we're also going to have here at 5, and we're going to add 9 there as well. All right. Okay. Now this is really important here, so for that. All right. Okay. Let's look at the next part here. All right, step 4. Step 4 says, okay, factor the side with x's in it. Now, I did put a, wait, my bad. Why do you divide 6 by 2 in step 2? So that is the crux of completing the square. Now, the reason is that why we do that is exactly what happens here in step number 4. All right, Fritz? So in step number 4, we want it to actually factor in a particular manner, okay? Because what we want is the predictability of what will happen if we do step number 3, okay? We want it to predictably actually factor to a very specific equation, all right? So that's one of the things about completing the square that is very helpful, even if it is a longer process. It is predictable in its nature, especially about how we can factor that left-hand side in this case, because as you can see here, the note here in step number 4, it actually will always factor to x plus b over 2 squared, meaning to say whatever you did here in step number 3, when you took that b divided by 2 and squared it, well, that's exactly what it's going to factor to, because you set up the problem in exactly that way. So what does that mean here in this case? So if you see here, all right, so to kind of answer your question a little bit further here, Fritz, if we see here, we have b over 2 squared, we have b over 2. B over 2 here is 3. That's right, we did 6 divided by 2, and 6 divided by 2 is 3. So no matter how ugly this looks here on the inside, you could have a 5 here, okay, and that's perfectly fine. Well, it's going to always factor to, say, x plus 5 over 2 quantity squared, or whatever, you know. It will always factor that. In fact, that's why it's very helpful here in this process. So if this is negative, it's negative. If this is positive, it's positive. But here on the left-hand side, I don't have to guess. There's no reason for me to guess what it factors to, because it always predictably factors to x plus that b over 2 quantity squared. So that's why we go ahead and take that 6 divided by 2 in step number 2. So that, again, try and make it as easy as possible. On the right-hand side here, we get 14. So that's perfectly fine. Okay. Okay. Now, next part here, last part here is solve for x using the square root property. So we've talked about that already. So we're just going to take the square root of both sides, and we're just going to solve for x. Enough. So take the square root of both sides. Here we get x plus 3 is equal to plus or minus the square root of 14. Fortunately, it doesn't simplify to anything nice, so just stuck with plus or minus root 14. We'll subtract by 3 on both sides. Simple enough. And so here we're going to get x is equal to negative 3 plus or minus the square root of 14. So plus minus 3 plus root 14 minus 3 minus root 14. Those are your two answers for the price of one. Easy peasy, lemon squeeze. All right. And that is how we can do that particular problem there. In this case. All right. Any questions about that? So you always take the number Uh, so you always take the number when divided by 2? I'm a little confused about that question. What do you mean you always take the number when divided by 2? Are you talking about B? Um, kind of clear. How we got? Oh, okay, yeah, okay, all right. I just wanted you to clarify. I'm like, I wasn't sure about that. Yeah, step 4. Yeah, it will always factor to this. That's right. So whatever you got here in step number 2, like when you took that B and divided by 2, like here inside the parentheses, right? That's what it'll factor to once you get down to that step there in step number 4. So that's what it will always happen once you do that, completing the square part there. So, oh, and these square roots will always come out to be plus or minus the in the final answer. Yeah. So, yeah. Remember, when we take the root of something here, we are going to do plus or minus roots. Okay. So plus or minus is always in play here for roots in these particular problems. It's kind of weird about math, I'm going to be honest. Some concepts only use the positive result, some concepts use both the plus and minus result. So I'm going to let you know if plus or minus is in play or is just the positive answers in play. In these cases here, plus or minus is in play. Okay? So I just want to be sure that that's clear there, okay? All right. Now, we're going to do one more problem here for this one here. I know I'm kind of running over time here for this section. There's a lot going on here in section 1.5, but this is basically a good foundation for a lot of the other things we'll be doing. So, and I need to do this last problem here, so that. Actually, no, not that one. I don't like that one because it's too simplistic. I can roll with it. Okay, I can roll with that. It's fine. All right. Okay, so let's do this other example here with completing the square. All right, so we get 2x squared minus 4x minus 1 is equal to 0. Okay, now what I want to point out here specifically is we're going to go with step number 1 here. And this is where I'm going to point out what the big difference is. We're going to do the same thing here that we did in the last problem. Okay, we're going to still move the minus 1 here, move that to the other side. That's perfectly fine. Okay, so we're going to have the 2x squared minus 4x equals 1. However, I'm going to do one thing that is slightly different here. All right. So I'm going to put a note here for this particular problem because of how important it is as part of the process. At least if you see this situation pop up. So we'll put a important note. Important. Okay. If you have a number in front of x squared, so if you have like an a that's, if you have a number that's front that is not 1, then factor it out. Factor it out before you start step 2. So what we're going to do here specifically, once you're here in step 1, you say, okay, I say, all right, there is a number in front of x squared. That happens to be 2. You're going to forcefully factor that number out. It doesn't matter what number that is. It doesn't matter if it factors nicely or not. That does not matter. What matters is I need to factor that number, whatever it is, in front of x squared. So what I mean by that is I've moved everything over from one side to the other. I got x's on one side, I got numbers on the other. That's perfectly fine. But I'm going to factor out this 2 on purpose. So I'm going to have 2, I'm going to have x squared, I'm going to have minus 2x here. After you factor that out, yes, that still counts. And then I'll have this equal to 1. And this is what I'm going to be starting to work with here once I start step number 2. Okay? So we are going to have to force ourselves to actually factor that out here prior to doing so. Now, why is this important here? Well, because of what happens here in step 2, this is why it's so important. Because in this particular case, we take b and we divide that by 2 and we square it. That's what we have to do in step number 2. However, b here is now different. Because we factored out the 2 here, what we're left over is that b is now negative 2. So we're going to take negative 2, we're going to divide it by 2, and then we're going to square it here in this case. So that one little adjustment that we made here in step number 1, because we have to actually make that adjustment, we are not given a choice. All right, that also changes that b term that we're going to be using here in step number 2. Here we get negative 1 quantity squared, we get 1 here. Now the rest of the problem here is almost the same. Almost, I say. Not completely, though. Let's talk about the rest of this. Let's talk about step 3. Step 3, we rewrite the problem here exactly as we have up above, only we're going to add that 1 here to both sides. Well, kind of. So, okay, we're going to add another important note here in just a second. Write this out here. So here we're going to go ahead and add 1. This is what we have here from before. Okay. Now, the other note that I'm going to make here specifically is this. So note here. Remember to properly compensate uh, compensate on both sides of the equation. All right. Now you're probably saying, whoa, time out. What does that mean? Remember to properly compensate on both sides of the equation. Let's take a look here. In purple, I put in a +1. That's what I put here. In purple, I put in a +1. I said, okay, that's fair. All right, I put in a +1 there. Now, normally I would add 1 to both sides. Like in this last example, I put +9 and +9. I said, okay, fine. But let's look at this carefully. If I put a +1 here, how much did I really add to the left-hand side? How much did I really add to the left-hand side? Did I add 1 to the left-hand side? How much did I actually add in that case? What do you guys think? You added 2, right? So we look at it this way, right? If I add 1 here, remember, we still have this 2 floating around out here. So in fact, what you added to the left-hand side is you added 2 times that 1, which is 2. So we want to add the same amount. We want to play a zero-sum game, right? So I'm not just going to automatically add 1 to the right-hand side. I'm actually going to add 2 here to properly compensate for the 2 that I actually added to the left-hand side because of this extra factor out here that I have to keep in mind about. Okay. So I want to point that out here. All right. So very done, Stephen. Very good. So I want, correct. It's exactly like balancing a scale. That's why algebra is specifically the word balance. All right. This is always true. All right. If you always think of algebra as the word balance, then this class becomes significantly easier because that's essentially what you're doing here at the end of the day. All right. Is we do a lot of balancing in this class. That's essentially what we do. All right. So when we add and subtract, multiply, divide, that's all balancing. It's all a zero sum game. It's all the same thing. Like that's essentially what we're doing here in this case when we're talking about completing the square. We're saying, okay, it's a balance. I said, okay, that's fair. All right, I got no problem with that. Okay. So yes, that is exactly what we're setting out to do. So that's kind of the mindset I want you to kind of walk in with. Yeah, no problem. Look, that's the important part here is is exactly explaining that because it's just you don't want to be like super overwhelmed. You don't want to be super overwhelmed. You want to be like, okay, how do we take this and pick it apart one piece at a time? That's what we got to do. We got to do. And we're getting there. We're getting there to that problem. We're almost there. Getting there though. So let's take a good look here at. I want to take a good look here at least what we have here so far. So you're just adding the 2 on the other side. Does it cancel the 2 on the left? The answer to that, are you talking about this 2 here? No, 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 not that 2. Not this 2 on the outside. We're going to be doing something with that, but that'll be part of the calculation here after the fact. So let's at least take the 1 plus 2 here, okay? And then we're going to do the factoring part here. So that part's still going to, yeah, we're still working on it. That's right. So we're going to still do the factoring part, and then we'll solve it right after we do the factoring part. So that's the plan here in this case. So if we do that here, okay, so we do step number 4 here. We say, all right, well, we factored the x squared minus 2x plus 1. Well, we already know what we got for b over 2, which was negative 1. So this is going to be 2 times x minus 1 quantity squared is equal to 3. And now we just do exactly what we set out to do here. We do the square root property here. So if we're going to solve for this here specifically here in step number 5, we're just going to divide by 2 on both sides here. So we get x minus 1 quantity squared equals the square root of 3 halves. I'll talk about this here a little shortly. And space, man. So much space, a little time. Okay. Okay. So we're going to take the square root of this of x minus 1 squared here. So we're going to have x minus 1 is equal to plus or minus the square root of 3 halves. Now, the square root of 3 halves actually, just to kind of highlight this here, again, you can split this up into 2 individual square roots. You have the square root of 3 over the square root of 2. One of the things about square roots, maybe from the Wayback Machine, is that you'll have to rationalize square roots. So to rationalize square roots, you would multiply by the square root of 2 on the numerator and denominator, the top and the bottom. So this will be the square root of 6 over 2. So we get plus or minus the square root of 6 over 2, which is the same as the square root of 3 halves. And then we just, I still don't understand how we went from 2x to negative 1 from step 4 to step 5. All right, so this is basically, all right, so Bernice, this is basically where we factored this x squared minus 2x plus 1. That factored to x minus 1 quantity squared. This 2 out here is this same 2 that is out here. So it is not 2x, it is actually 2 separate parts. So you're trying to put 2 of those together, Bernice, but in reality, they're 2 separate parts. I factored out the x squared minus 2x plus 1. That's this part, x minus 1 quantity squared, and that's the 2 that we brought down. So that's all we did. That way I'm not confusing the two. They're 2 separate things to me. All right, cool. All right, we're going to add 1 here to both sides. And we'll get our final answer here. X is going to equal 1 plus or minus the square root of 6 over 2. Yeah. Yep. All right, good stuff. So that's our final answer for that problem. All right, good stuff. All right, a lot of things to kind of like over there. Yep, let's look at it one more time. So I didn't simplify the square root of 6 over 2. That's what I got for the square root of 3 over 2. So if you look over here, the square root of 3 halves is equal to the square root of 3 over the square root of 2. And then you have to rationalize the denominator because you can't have a square root in the denominator. So in order to simplify that, we multiplied by the square root of 2 on the numerator and denominator. The square root of 3 times the square root of 2 is equal to the square root of 6. Since you have this, square root of 3 times the square root of 2. Again, you can combine that into one square root, the properties of square roots. And so that's where you get the square root of 6 from. And square root of 2 times the square root of 2 is just basically canceling out the square root. So that's just leaves you with 2. And then that's it. That's how you get square root of 6 divided by 2. So that was just me just kind of simplifying this part down. Any other questions? Oh, wow. Look at these questions that I see right in front of me. These questions. Do I want to become famous? I'm already famous. Look at that. Bam. Now you're famous for being on the ban list. Amazing. All right. Lovely. All right. Moderation so easy. All right. Okay. Any questions about completing the square? Oh, I didn't mean that. Can I explain 4? Like step 4? Or are you talking about step number 4 there? Okay. I was gonna say number 4, it could be like the one on the handout. It's like, okay. All right, so here we have 2 times x squared minus 2x plus 1. So remember that this always factors x squared, again, x squared minus 2x plus 1. That will factor to x minus 1 quantity squared. Again, you don't have to guess about what it factors to. You automatically know, right? You automatically know that automatically factors to b over 2 quantity squared. That's just part of the steps that we have here when we do completing the square. This 2 here is on the outside, so this 2 that was on the outside here from before, that's going to just make its way down here. And then whatever we have on the right-hand side here, we have 3. And then we just go ahead and divide by 2 on both sides and take the square root of both sides. And then see what we get here at the end of the day. So that's what we're at. That will be how we get to step number 4 there, and how we have that. Okay. That one slipped your radar. That's perfectly fine. What we're here to cover. No problem. No problem. No problem. Right. Oh, Steven says hydrate. I said, all right, that's fair. Here we go. Any other questions? Any other questions? Hopefully that made it a little bit easy. There's a lot of examples here, like that. 1.5 is a pretty stacked section. So there's a lot of things in this section. In all honesty, this is probably one of the heavier sections. So yeah, of course, yeah, certainly that's definitely something you can see. Absolutely. Hopefully you get a good look at these steps in here. And there we go. So that is the question number 9. Or did you want to see steps for the other processes? Let me make sure that at least I'm not going absolutely banana-ramas. Get it done. Mm. All right, E-Man's looking it over, so all right. Nope, just the notes. Fair enough. Fair enough. Nothing wrong with that. That's why I'm here to take questions, make sure that he goes. Yeah, yeah. It's right in front of you, my dude. The notes, you got it. You got it. Josh checks his blink. Thank you. Thank you very much. Um, no problem. I'm here to help. All right. I have time. Technically, I do have a little time. You know what? It's 15 minutes, so yeah, it's gonna take me. Yeah, that's gonna take me a little bit of time. Okay, gonna take me a little bit of time. That's fair. That's fair. I didn't expect section 1.5 to take like an hour and a half or so, but it did because it's just really a it's a chunky section. Okay, it's a very chunky section. It takes care of a lot of the fundamentals that we're going to be seeing in the class. So because of the high amount of fundamentals and the kind of a lot of explanations, a lot of steps, you know, it does take longer than most other sections. The rest of these sections don't take as much time as, say, probably this section. So we're going to definitely get through 2 sections here for tomorrow. So that's the plan here. We're going to. I wanted to get started with chapter 2, but you know what? Sometimes that's just going to happen. So um, we can make up that time without too much trouble. That shouldn't take me too much time to play catch up a little bit. But I think I want to get everybody at least hopefully the first couple days get a little bit get acclimated here a little bit, and then kind of start working our way forward. That's kind of important there. So you have a question related? Yeah, go ahead, Danny. Absolutely. Ask away, my friend. I know there's still some details that I'll probably have to fill you in about. Can you also access the documents that you're showing? Right. So you have the handouts there. Will the chapter 1 info focus on the info in yes. Okay, so let me yeah, so there's 2 really good questions there. Let me go ahead and clarify for certain things. Number 1, anything that I show you here as lectures and on stream are fair game for test questions. However, anything that I do not cover are not fair game for test questions. So if we don't cover 1.2 to 1.4, you'll never see questions from 1.2 to 1.4. If I don't cover certain topics within certain sections, even if we do that section, if there's certain topics we don't cover, That will not be on a test, okay? That's just not fair. All right? So what you see is what you're going to get on an exam. Okay, Danny, that is I try to be, like I said, I try to be as transparent as possible. So what if yeah. Yeah, I'm not going to be like, "Oh, you just automatically, you get this question from out of nowhere." It's like, "No, you don't get a question out of nowhere that we never covered. That's not fair to anybody in class, okay? That doesn't make any sense at all. All right. I try and be as clear cut as possible. Says these are the expectations. This is what I'm showing you. This is what you're going to get, and nothing else. Okay. I promise you that. So I try and make tests always to reflect that at any moment in time. Can we also access these documents as showing? So you can find these on D2L, Fritz. Again, they're the blank ones of these notes. Okay, so the things that I have filled out here, you won't see online there, Fritz. And on D2L, distance to learning, you get access to all the blank documents with all the questions on it. So all the handouts there. So you can find that underneath. Let me go here. It is. Let me here. I showed that off the first day there, so maybe you're a little late for that, which is fine. Um, so that is underneath this website here. Again, you'll need to register. You'll get to this page here, and then you'll need to put in your username and password and whatever. That'll be provided to you by ECC there, Fritz. And then you're gonna get to your D2L page. So let me go ahead and log in one more time. Okay. So you're gonna get a page that's similar to this. All right, and you click on Math 112, you'll see an announcement here, and then if you go to this, if you go to content, all right, and then you see all the handouts here. Again, there's the blanks there, but again, you'll have access to those, no problem. So yeah, should be should be fine. Any other questions you guys got? Any other questions you guys got? Nope. Okay. Fun question. What made you to decide to be a math teacher? Oh, it's something that I picked up over time. I just happened to be decent at it. But second handout says unexpected server response. May want to just refresh, Khadija, see if it works the second go around. Or you can download the document too, by the way. So if it doesn't let you see the document, you can always download it, and you can always see it on your computer. Um, well, okay. Yeah, just try downloading. It'll be easier. Well, Nicholas, the story goes, well, I didn't know I wanted to be a math teacher until I went to grad school. Until I went to grad school, and then I thought about something that happened to me in high school, actually. Um, oh, this is the new notes here, so I think you want the old notes here, Josie. Yeah, out here a bit. There we go. You put here on 5, 6, 7, and 8. Hopefully that'll help you, Josie. Oh, 2, 2, 1. Yeah, I haven't gotten to 2, 1 here yet, but if you want me to put that up, I can. This is just the first page here, so we'll talk about 2, 1 here for next time here. Have I ever built my own PC? Of course, many times, Blink. Many times. I built my own PC. The PC that's sitting next to me, I built, so no problem. Yay, yay! Got some RGB goodness in this thing. Darn right, build your own PC. It's so much easier. I build my PC every single time. Now I want to answer Nicholas's question because, like, when I got into grad school, I had to teach for grad school. That was one thing that I had to do. For grad school is I had to teach along with getting my master's degree. Actually, originally I went from a PhD, and I'm like, I just want to do a master's because it's just kind of the thing that I did. Um, you're in the process of picking a motherboard and CPU. Have fun. Getting a motherboard is easy. The CPU, let me tell you, getting a chip these days, Blink, is a pain in the backside. Secondary market is absolutely crazy because there's such a shortage of chips out there. So if you're looking to make a build, make sure you have good connections if you can grab a CPU chip that isn't out of stock. So yeah, them scalpers are terrible. So teaching wasn't something that came natural to me. I was super nervous. Like my first day of teaching when I was at the University of Kansas when I was in grad school, because that's where I went to school, was the KU. Is I was super nervous. I didn't know what I was doing. I had no idea. In fact, I remember I was teaching the math class for my math class for the first time, and I literally had the attendance sheet in my hand, and I'm like, I looking at the attendance sheet, and I got so nervous that the attendance sheet was shaking in my hands, and I accidentally dropped it on the floor. And I'm like, well, I kind of looked at myself. I'm like, what the heck am I doing? I have, uh, oh, if a friend gave you a spot, then that's cool. Then yeah, pick one up. Fine. Um, I was so nervous. I didn't even know I was going to be a math major, to be honest, because I had done so bad in math for quite a while. I mean, heck, maybe my first calculus class I got a C in because of my freshman year was just so bad. But I will say this. One of the things one of the things that really stands out to me is something that happened to me in high school and why I think being a teacher probably was the best thing for me. So it was actually during a math class in high school. So it was my junior year of high school. My junior year of high school, basically, I was doing this class. It was a GTA, before GTA was a thing, and that is geometry, trigonometry, and algebra. All right, and I had this teacher, and she absolutely didn't like me. Now, notice. Now, I'm gonna put a note here. This was during the '90s. The '90s weren't that great for a person like myself. All right, especially when you're like when you're only one of the only one of the brown people in a school like that. You're like, you kind of stick out like a sore thumb. That's just how it was. I mean, that's not how it is today in my hometown, but that's how it was back in the day. So, um, thing was that what do you do if you struggle in a subject, right? If you struggle in a subject, you go and ask the teacher for help because you know what? That's the person that has the knowledge. That's the person you want to get help with. So I'm like, I'm struggling really hard. I'm putting in a fourth effort. I'm trying to do good. I'm not the best student in the whole wide world, definitely. All right, but I am putting forth my best effort. So I'm asking. I go to her office. I ask questions. I'm gonna try and make sure that I'm understanding this material. I'm having a tough time. And she would always give me like the snide looks and whatnot. And she always give me the snide looks and whatnot. And don't worry, you'll see these notes tomorrow, by the way, as well. And then finally, she was getting angry and angry with me for whatever reason. And, she would throw in the kind of shade comment that wouldn't be particularly nice, like not the greatest comments. I'm gonna be honest with you. Um, but one day she's sitting there and she's helping another student. She's perfectly fine with the other student, but she's not fine with me. And I already knew why. It's not like I didn't know why, but it is what it is. And finally, she turns to me. I asked her another question because I wasn't sure, what was going on. And she turns to me and she says, I still haven't forgotten to this day. She says, Professor Chibbs, You're not worth helping. That's what she said to me. I still haven't forgotten that day. Now there were a lot of other things. There are a lot of things that were going on in my life during that time. It wasn't look, you know, why would you see me next Tuesday? I'll be here tomorrow. Wednesday, we're meeting tomorrow. Yeah. Is that that's what she said to me, right? I was of course I was really hurt. I was really hurt. I walked out of there, picked up my stuff, walked out of there. I literally cried. I was crying. Was there are other things going on behind the scenes that weren't that great either that really didn't help. And so when I got to be in the position that she was in, when I got to be uh I'm not going to sit here and say it was easy. There are things that happened in high school that were ugly. That were you know completely ugly. That's another story for another time. I will say this: when I got put in the same position that she was, I remember back to that moment, right? And I said, "Oh, you know what?" I said, you have a couple choices. You could say you could be that pessimistic, or you be that person that sticks out their hand and wants to help others. You know, I said, there's nobody not worth helping. Everybody brings something positive to the table. It says you sign up for an education. You want to be able to help yourself. And I want to be there to help you. I want if you're not willing to help yourself, then I can't help you. But if you're willing to help yourself, then I want to be able to stick out my hand. At least that there's at least somebody out there that can reach out their hand and actually want to be able to help you at the end of the day. That's what I strive to be. That's what I strive to be as a teacher. That's what I want to be because I don't want to be that person that says, "You know what? You're not worth helping." You don't want to be like that's terrible. Like in high school, I mean, I'm sure that's one thing. In college, you're trying to work to be a better person. You're trying to be a better self at the end of the day by, doing education and working your way up, you know. The job is inherently going to be tough. Sure, I agree, Nanny. It's inherently tough. Absolutely, it can be tough at times. There are times where I complain too. But you know what? I always think back to that point. I said, you know what? For all the good and all the rough times that you can have sometimes, and sometimes, like any job, you're going to have stressful times and stuff like that. It's always it's always good to remind yourself, you know what? It's always worth helping. It's always Everybody is worth helping. Everybody's worth having a hand that can hopefully lift them out. And if it changes their life, it changes their life. If it changes your life in just a little bit of a way, it changes your life in just a little bit of a way. That's how it is. That's how it is. At the end of the day, I want to see all of you, to be in a better position than where I am sitting right now. Okay, that is what I would like you to be in. That is where I would like you to be. If you end up making more money, or having a good time, or having a job that you actually like doing for the rest of your life, guess what? I won. I set out to do what I wanted to do for you. And if it means that I have to be a stepping stone to that, if I reach up and I have to pick you up out of the abyss, I said that's fine too. Because I've been there, I've done that. I don't like being in that situation, and neither will you. I don't want you to be in that same situation. You get a shout out if I make it. I appreciate that. I appreciate that. So it's important. It's important for everyone to recognize. 2024. Thanks, Dan. You have a wonderful day as well. Um, but yeah, that's look. That's why I like teaching math. That's what got me into teaching, is like just remembering those times where I had to struggle as a student, and I had to be, I had to be the one um, that had to suffer through things. I said, you know what? Now I have the power to actually do something about it. Let's do it. Why not? You know, Math happened to be a subject I was good at once I finished my undergrad. And I want to trust me. I went through my own struggles, as I told you yesterday. I almost failed out of college, once, so it's not like I didn't struggle, but math is what I got used to. I also have a degree in computer science. I haven't used that in like 20 plus years, but you know what? It is what it is. Um, but yeah, math is what I got along with, and then that translated into this somehow, some way. Like I enjoyed teaching more than I enjoyed, for me, I enjoyed teaching more than I enjoyed just doing the studying and stuff and getting the master's degree. I could be honest with you there. Yeah, some subjects don't meld well with others. That's fine. That's fine. Some subjects don't meld well with others. One subject that doesn't meld with me, which doesn't make sense to some people, but it's physics. Me and physics are not good friends. I don't understand. Me and physics just doesn't seem to get along. We're not good buddies. Now I like the fact that physics exists, mind you, but you know what? It's just one of those things that I just don't do very well. That's fine. I mean, I even recognize this fact. Not everybody is made for college. That's another thing. My best friend, he's a military lifer and he never went to college. He tried. It didn't work out for him. He didn't really go to college. And you know what? He is now an IT for a big corporation. Like, okay. It worked for him. Like, you know what? That's just how it works for some people. And to me, I'm like, okay, that's true. Some people work better with their two hands than they can with the book. And academics may not be the best thing for them, but they're just as good. Uh, they're just as good as a person that does have the degree, 100%. Yeah, it's totally true. I may be an academic guy who works in academics, but it doesn't mean I discount the people who don't have a degree and can do just as good. You recognize them by their productivity and their merits. That's the important part there. Like I don't like when people like put people down just because of that. Like that doesn't make any sense. It makes no sense to me. Life is crazy. Yeah, it's very crazy that way. I don't always feel like a piece of paper is necessarily going to be the end all be all for everything for every single person. For some people it will, and for some people it won't. And it's not fair to categorize that it has to be one certain way. So there's things that I think about, kind of behind the scenes. It'd be like, yeah, those things, sometimes they're applicable. Absolutely. That is a good question. It's a good question why I want to get into math teaching. Um, I know I kind of went off the rails there, but still, fair question. Absolutely, fair question. Absolutely. Thank you for the hydrate, Khadija. Appreciate that. I want to do so much more in my life right now, but with the way my parents are, if you don't go to college and get a good degree, you automatically failed in life. So are we talking about doctor, lawyer, engineer? Is that the three choices that you've been given? If that's what you're referring to. You got to be a doctor, lawyer, engineer almost. Let me tell you something. Doctor, lawyer, engineer, that's all nice. Okay. You have to go tomorrow. You have a good rest of the day. Thank you, Nicholas. You have a great day. Josie, you have a wonderful day. We'll see you tomorrow. All right, have a wonderful day. Um no, I'll be honest with you. Um uh I said hell no, I'm gonna do what I want. So he said something tech. So he said do something tech related. Yeah, that's why I did computer science. My mom's like, yeah, you can don't do computer science. Everybody's doing programming. I'm like, yeah, there you go. That's fine. But you want to know something? It took a long time for my mom to even acknowledge. Okay, it took a long time for my mom to even acknowledge that I should be a math teacher. It took a while because everybody's always thinking a doctor, lawyer, engineer. You should get the best paying job and everything like that. But you know what? I worked in a corporate environment before. I felt miserable. It wasn't my deal. Just not how I can do it. Now I agree you should be financially independent, 100%. All right, but not to the point of where you're making yourself completely miserable. I mean, that's just rough, you know. Wanted to do culinary, but every time I tried or got close, it went wrong. Now I'm really hoping to get into Purdue so I can pursue veterinary. Okay, there's a lot of things that you can go ahead and explore and do. You know, it's true. One thing that is true, Khadija, that is backed up by some statistics, is that people 50% of students will change their major at least 2 to 3 times in their entirety of their undergrad life. I mean, so if you change your major a couple times, change your major 3 times, perfectly acceptable. Most students do. So my first major was what, psychology, then it changed to like geography, then it was like math and CS, and yeah, there you go. I'm no different. I'm no different. I had no idea what I wanted to do, so I'm like, all right, let's just try stuff. Animal doctors for the win. There you go. You're not okay. Fritz says, I'm not really sure what I want to do after the ECC. Look, I understand you're feeling pressured. You know, once you hey BMC, my options trading ain't going that great. I'm gonna be honest with you. It's been a little bit of a rough go this year. It's been a little bit of a rough go due to the volatility in the market. So I understand if you guys are in the same boat, you know, and you're stressing out about what you should choose, but think about a subject that you think you can long term have fun with, you know? Think about a subject you can have a long term job you can have fun with. And that can be really applicable. You know, yeah, I'm still doing condors. Yeah, I'm still doing condors. I can't help it. I can't help it, BMC. I can't help it. I have to do condors, man. It's too tempting to do condors. Like no lie. Yeah, option selling is hard. It's true. Yeah, look, I'm gonna be honest with you. I did a lot of jobs when I was younger. I'm not the perfect, you know, I don't make a ton of money. I don't trust me. I don't make the most amount of money here. Um, I don't make a whole ton of money. But what I do is that you work enough to be financially independent and do what you want to do, and then you can be happy with that. And then that's what you're aiming for. You know, to do those things that you want to do later, and you're building up upon that. That's essentially what you're doing. There's nothing too fancy about it. Um, but you should do a job that you enjoy, because you know, and sometimes you have to bite the bullet a little bit. But if it gets you to the point where you get to a place where you're going to be happier, then perfect. Yeah, when I wake up and do this, I have a lot of fun too. Jess has a question, and so has BMC. Absolutely, you guys can go ahead and ask questions. You guys redeem. Absolutely, good idea for putting teaching on Twitch. Getting that side money for donations. Trust me, I don't ask for subs or donations. I barely do. Khadija, I barely do. I don't, you know, subs and donations are just a side thing. But I don't make that the goal of the channel. The goal of the channel is to educate, you know, for class time and get to know things and you know have a little fun on the way. What's my dream vacation after COVID? Oh, that's easy. I know exactly where I'm going after COVID. That's going over to England once things have settled down. I have business to attend to in England. Um, particular business to attend to in England. Do I do condors on the S&P? How far you put us at yes. Yes, I do. Brianna, hello. I am doing great. I do condors on the SPX. Yes, I do. Take me with England's been a lifelong dream for me. Oh, there you go. Yeah, look, I got some peeps I gotta meet, and it's been a long time coming. It's been nearly a year now, so um I'm a big fan of a particular soccer club over there. There you go. Big fan. So, how you been? How you been, Brianna? It's going well. It's going well, Brianna. Manchester United? No, 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 my friend. You have a good one, Khadija. You take care of yourself. I am a big fan of hashtag United. Hashtag United. They are in the. They're a non-league team. They're in the 7th tier of English football. Absolutely an outstanding team. Absolutely lovely. I'm a huge, huge fan. I got like two of their home kits that follow the team. I've gotten a chance to talk to a few people on the team. It's really a super fun club to follow and be around. If you look up hashtag United, it's really good. Trying to be my yeah. Look, I know you'll do well. But yeah, hashtag United. If you find out more about hashtag United, I know you for a fact that you'll just have a lot of fun. Just go on, just you're a fan of a football team. You can be a fan of like a soccer team that is the big guys like Manchester United, City, Liverpool, Tottenham, Chelsea, Arsenal. Those are the big six. But hashtag United is much more fun. It has those grassroots feeling. It's super fun, super exciting. Hey, thanks. Teacher Master Summer. Yes, yes, I am. Yes, I am indeed. I get to have a lot of fun with a lot of different other people. Look at that. 100%. You can't go wrong. You can't go wrong with a day like today. Wahahaha. Can you do a stream where you teach how to adjust condors when shit goes wrong? I mean, yeah, I can. I mean, I'm not perfect at it, mind you, because I've lost money this year. But there is a way to kind of like, there's a kind of a way to kind of adjust condors. Like, it's not super easy even for me. I'm not gonna lie. But there's a way you can adjust condors. Yes. It depends how bad shit went wrong, though. Yeah, that's a language. Yeah, sorry about that. You gotta remember. Yes. Jess is correcting me. Thank you, Jess. Uh, oh man. Nah, that's all good, buddy. It's all good. But yeah, condors can be condors are condors you kind of have to read a little bit on the chart there if you want to do like a good proper condor. So there is a child among us. I don't know if he left yet. Oh, I see. Wait, there was? Well, I don't even know anymore. Okay. Who's the imposter, Jess? Who's the imposter? somebody among us. Who's the imposter? Yes. Do I game? Yes, I do actually. I play COD Cold War right now. Right now is Call of Duty Cold War. When I'm not working, of course, though. Yes. Call of Duty Cold War. All right. Okay, it's 2:07. I think it's about time for some lunch on my end. So, gotta save that. Yep. All right. So, ladies and gentlemen, and BMC, by the way. Yeah. If I have some free time for you, I can certainly show you how to do some condors and stuff like that. You know, to kind of make adjustments. Um, the timing is kind of important if you want to make adjustments. So, it'll be kind of helpful, especially with SPX. You have a little bit more leeway, though. I say a little bit. I won't say a lot. Um, all right. In any case, I want to thank everybody here who came out here for the stream. Yeah, absolutely. I want to thank everybody for coming on out here to the stream once again. I'm going to be back here at 6 o'clock here later today. That's in 4 hours for my Math 126 stream. In the meantime, though, for those of you who have come on to my stream, I want to thank you again very much. I love you all. All of you make these streams super fun and super exciting. And as always, ladies and gentlemen, stay safe, stay healthy, but most importantly, stay sane. Have yourself a wonderful day, everybody. We'll see you tomorrow at this same at noon. All right. See you tomorrow at noon. Yeah, no problem. I'm here to help. Limit. Ask fun questions and asking those things certainly very helpful. Hopefully very helpful. All right. Take care, everybody. We'll see you tomorrow, noontime, same time, same place. I promise you, right here on Twitch. All right. Take care, everybody. Have a great one. All right. Bye.